LeetCode problem number 78, subsets. So this problem gives us an integer array of unique elements, and what we have to do is to return all the possible subsets. And the solution must not contain any duplicate subsets, and the result can be in any order. So the subsets in this case would mean every single combination. I think it explains here. Selection of array. Okay, so basically it's an array of all the possible combination. For example, for 1, 2, 3, we have 1, 1, 2, 1 and 2 in a list. 3, 1, 3, 2, 3, and 1, 2, 3. Right. So these are basically the list of all possible combination this number can give, including empty list. Okay, so my solution to this problem is to have to use recursion, and the way I did it was I would on the left, I would say on the first time I would push the number into the current vector that I save here, and once I've added that in, then I remove it so that we get both possibilities of added and not added arrays, right? So let me explain. So let's say 1, 2, 3, right? So 1 and 2, 3. So starting off, we can decide whether or not we want to put 1 in, right? Whether or not we want to put in. So let's say this is we put, this is we don't put. So when we put it, so we have 1 here, and this will be the empty. Okay, and then once that's done, so we decide whether you want to put 2, right? Sorry, this will be 2, 2 plus, and then minus. Let me remove this here. This is 1 plus or minus. So here we can decide whether you want to put 2. So if you do, then we have 1, 2, and here we don't put, so this will be 1 only, and this will be split up again. This will be 2, this will still be empty, right? Because this is also the plus and minus. And from this, I can branch out again for 3 plus and minus. So here, if I do put, then I'll have 1, 2, 3. If I don't put, then I'll have 1 and 2 only. Okay, for this one, if I do put, I'll have 1, 3. If I don't put, I'll have 1, 2, 3. If I don't put, I have 2. And for the last one, if I put, I'll have 3 here. If I don't, I'll have the empty list. So you can see here we have 1, 2, 3, 4, 5, 6, 7, 8. Right? All of these are basically the answer that leads to our output. So you can see here, by having a decision tree, something like that, we can decide, we can basically have all of the combination of the subset, right? So basically that's what the recursion is doing. The recursion is doing this part, and then this pushback would be the plus, this pop back would be the minus. Okay, so in code, it does not produce a result like this perfectly, but this is the idea behind it. So let's talk about the code. So I'm going to use the example 1, 2, 3 again. So it's going to be like this. Okay, so first of all, I have a current. So this current will basically store where we're at, right? So this is the current, this is the current, right? This is the current, and when we push back, we are pushing back the current. And then we are starting with the nums. In this case, will be the starting index, right? This will be the index. And num is basically what we put in, what we receive as an argument from the subsets function. So we have the result. Right now it's empty, and we have the current. Right now it's empty as well. We know nums is 1, 2, and 3. Maybe I'll do 1 and 2 only so that this will be shorter. Okay, so first thing first, when we enter, we push back the current, which is currently empty. So right now our result looks like this. And then for I equals to n, in this case n is 0, which means that I is starting from the beginning of our nums and up to the num size, which is 2. So current now push back the first number. So our current has 1 in it. And then we recurse. So with recursion, I'm going to open a bracket like this. We recurse nums, current, and I plus 1. Okay, so I'm going to put n equals 0 here. So now n is equals to plus 1 is 1. We push back our current, so our result has this. And then for I, which is equals to 1, I is less than 2, right? Num size is 2. So we push back again, push back 2, and then we enter recursion again. So n is now 2. We push back once again, push back the current into our result. So now our result looks like this. And since now since I equals to 2, right, because n was 2, and I is not less than 2 anymore, so this for loop does not get executed, so we just instantly exit from this recursion. So when we are back, we pop back from current, which is from here, and then we enter the for loop again, right? The I will increment, so now I is equals to 2, and when I equals to 2, we exit this for loop. This for loop doesn't get executed. So when we skip past that, now we have to pop back again. So we're popping back this, and now n we increment, or in this case I we increment, and then you push back nums I, which in this case nums I is 2 into our current, and then we recurse again, right? Recurse again. So now n is equals to 2 plus I plus 1, and then on our result we push back the current, which in this case is 2. And when that's done, since n is equal to 2, it does not enter this for loop. So after it's done pushing back, it will exit this recurse, and then it will pop back the current, which in this case doesn't really matter anymore. But now that that is done, this recurse function exits, and then it will return our result, which you can see here containing all of the subsets of 1 and 2. Okay, this is a fairly easy example and a fairly straightforward problem and solution. Hopefully my explanation is sufficient. That's all I have to show. Thanks.